Numerator. So what am I going to have to do to my numerator? FOIL it. X squared plus 4x minus 5 divided by x plus 1. Alright, so my answer is going to go there when I start dividing. X will go into x squared how many times? X times. X into x squared, x times. X times x, x squared, x times 1, 1x. Subtract, subtract. Those will cancel. 4x minus x is 3x minus 5. How many times will x go into 3x? 3 times. 3 times 3x is 3x. And 3 times 1 is 3. Change your signs. -8. We have not had a quotient that looked like this. Okay? We haven't had a quotient that looked like that. So how would I write this if I was writing it in standard form? As quotient equals quotient, right here, I'm sorry, quotient plus remainder over dividend. How can my k equal all of that? It can't. Okay? So there is no horizontal asymptote. So if you get a binomial, there is no horizontal asymptote. I will tell you in a minute that that's going to be a slant asymptote or an oblique asymptote, and I'll show you how to get that in a minute. Okay, any questions on that? All right, let's go to the next one. What do I need to do to my denominator? FOIL it. So I have x minus 4 divided by, when I FOIL that, I get x squared minus 1. I put it in a box. You get x squared minus 1. So that really is x squared plus 0x minus 1. How many times will x squared go into x?
X times?
X squared into x.
X.
0. 0. That is my horizontal asymptote. 0. You cannot divide it into it. It will go 0 times. So you should be kind of seeing a pattern here. This had an x squared on the numerator. This has an x squared in the denominator as opposed to an x in the numerator. What would my end behavior be? As x approaches positive infinity, f of x approaches 0. As x approaches negative infinity, f of x approaches 0. Let's look at the last one. 2x squared minus 3x minus 9 divided by x squared minus x minus 6. There's where my answer is going to go. How many times will x squared go into 2x squared? 2 times. 2 times x squared is 2x squared. 2 times negative x is negative 2x. 2 times negative 6 is negative 12. Change your signs. Negative x plus 3. How do I write that as quotient plus 2 plus negative x plus 3 over x squared minus x minus 6? What is my horizontal asymptote?
2.
Y equals 2. As x approaches positive infinity, y approaches 2. As x approaches negative infinity, y approaches 2. Any questions? All right, now I'm going to sum it all up. You don't have to write all this down, but just pay attention because you might want to take a few notes over it. I'm on page 497. It's all in your notes, but what I did was just kind of condense it into words that I thought you might understand a little bit better.
It's on 197.
497. Okay, there can be breaks in the graph of rational functions. These breaks are called discontinuities, and there are 2 kinds. When a rational function has a factor in the denominator that is not also in the numerator, then a discontinuity occurs. It appears as a vertical asymptote. So what that's saying is, if I have a factor in the denominator that is not in the numerator, so let's say this is my problem. X plus 2, x minus 7 over x minus 3. Okay? It's saying, if there's a factor in my denominator that is not in my numerator, which this one's not up there, right? Factor here that's not here, it's a discontinuity. It is going to be a vertical asymptote. Because all you do is set this what? Equal to 0. So my vertical asymptote in this case would be 3. Okay? Because that factor was not here. Alright? Second part. When a rational function has a factor in the denominator that is also in the numerator. So it's in both. So it's going to look like this. Let's say that this factor is also x minus 3. Okay, so there's my problem. It says if there is a factor that's in the denominator and the numerator, both, which this x minus 3 is in both, it's not going to be a vertical asymptote. It's going to be a hole in the graph. You need to know that.
So negative 3, or 3, is going to be a hole in the graph.
It's going to be a hole in the graph.
The whole
So
line.
what does that mean?
I'm going to show you how to get the hole. But just know that it's going to be a hole and not an asymptote. There's going to be a circle on your graph.
Oh,
A hole.
wow.
Wow.
Okay.
He said wow.
So when you put it in the calculator, it's gonna make a circle.
It'll, yeah.
Error.
Error.
All right, so one more time. If there's not the same in the denominator and the numerator, then it's just a vertical asymptote. If it has a factor that is the same, it's a whole. Okay? All right, here's some rules on horizontal asymptote. Now, we just went through them all, but these are shortcuts, okay, to what we just went over. When the degree of the P of X, which is the one on top, when the degree of the P of X is less than the degree of Q of